where we're going to do it as a class lab. So this is going to be we're going to do this part of the lab right here. Sorry if I get this zoomed in. Okay, over here, this is the last part. Okay, guys, y'all listen up. Turn around. Okay, we're going to do the last part of this lab as a team. We're going to do this where it says class lab. What I want you to do on your chart where it says 5 votes, 10 votes, and 15 votes, we're going to change that to 30 votes, 60 votes, and 120 votes. Everybody okay on that? Okay. We're going to change the voltage over here on the last thing where we're going to deliberately break a diode over. But what we're protecting it with is we're protecting it with a 1 mega ohm resistor. What's the color code for a 1 mega ohm resistor? Brown. That's it. You got to do the second one. 5 zeros. We give you the first 0. Okay, so it'd be brown, black, green, right? Okay, so that's what I have here: black, brown, green. Here's the one in a 914. We have the positive pointing toward the cathode. We have the negative pointing toward the anode. So we're going to reverse bias this thing, and we're going to break it over. What I've got is I've got 2 meters that we're looking at. One of them is measuring the voltage drop across the diode, and then the other one is measuring the voltage drop across the 1 mega ohm resistor. We're going to use the 1 mega ohm resistor to calculate the current. So it's kind of like what you're doing with your regular lab. So we're going to measure the voltage drop across the resistor. This is the voltage drop across the diode, reverse bias. This is the voltage drop across the resistor. And then we're going to use the voltage drop across the resistor to calculate the current, right? Everybody okay? So what would be, so basically it's, what would it be, 1 microamp per volt on a 1 meg? Okay. So we're going to start off the first one, and I've got all these power supplies hooked up to series 80. Y'all understand that? Yes or no? This is something y'all should have learned in DC. So series 80 means we take the positive of one and connect it to the negative of the other. So I have 4 variable power supplies. I've got them hooked up series 80. We're doing 30, 60, and 120. So I've got 4 variable supplies. And this will be my positive. Then I've got them hooked in series 80. And then I come over here, this would be my negative. So we've got the diode in there like this. And then we got a 1 mega ohm resistor right here. I've got a meter across the diode. And then I've got 1 meter across the resistor. So they're calling this R1, I think. So BR1, it's 1 mega ohm. So I can calculate I of the diode by using V of the resistor, right? The R1 divided by 1 mega ohm. That's what we'll calculate the diode because it's a series circuit. And what's the same in a series circuit? Current. So this is the way we got this thing hooked up. Except mine, I got the diode on the right. So, and I didn't draw, sorry guys, and I didn't draw the arrow. If we see an arrow through an electronic component, what does that mean? It's variable, yeah. So I have the ability to adjust these power supplies here's my power supplies. So I have this guy, the minus on this one, jump to the plus on that one. I'm actually, guys, we actually have, I should have drawn this different. We actually have 8 power supplies up here. Now, the way the power supplies are wired in the trainer is they're wired like this. I mean, not the trainer. This is also true on your trainer. So your trainer, you got the plus minus up there, right? So this one, so this is the way these power supplies here are wired. They're wired like this. And then we have a stop in the center. This over here would go to the positive terminal. This right here would go to the negative terminal. And of course, they're using yellow for negative. And they're using red for positive. And then they're using black for the common. We're not using the black, so this is what we're wiring. So I've got this one, jump to that one, and then I go to the what? Then I go to the next one, and the next one, and the next one. These guys are rated at 15 volts, so technically if it's at 15, we should be able to get 30 volts out of this, so we should be able to get pretty close to 120. Everybody okay? So what I'm doing is I'm starting off with all of them set to 0, okay? So, by the way, a regulated power supply, you almost never can get 0 out of them. So even though all these things are turned down to minimum, we're still getting about, so even when they turn down the minimum, I'm still getting 10.6 volts out of them. Okay. We're going to start turning them up. So we're going to shoot for 30 volts first. This is across the diode. So that's close enough. So we're getting about 2.8 volts across the resistor. Everybody okay? Y'all can calculate the current. Just record the voltage, and then y'all can calculate the current, right? I'll take what? This is the resistor. So I'm going to take 2.8 volts and divide it by 1 meg. This is across the diode. This is what we're going to use to calculate the current with. Everybody okay? So there's current flow through the diode. Right off the bat, we know there's current flow through the diode, even though it's reverse bias. This is the current, right? So we're at, this is VR2 right here. This is the yellow meter. 1 meg. And then the current. Are we okay? Everybody okay? Then what we're going to next, we're going to go to 60 volts across the diode. So 60 volts across the diode, we got 5.7 volts across the resistor. Okay. Now we're going to go up to 120 volts. Y'all can see why y'all don't get to do this. Y'all can get zapped with this. Okay, that's the best we can do, but we'll go ahead and record that. So let's call that like 11 volts. Okay? All right. Now, next thing we're going to do is to heat it up. What I'm going to do is I'm going to come over here and take a soldering iron. So here's my circuit. I'm going to get into it because there's almost 120 volts. 120 volts here. And then we'll heat it up. And what should you expect to happen? The current, this voltage drop right here is going to increase. So here's my soldering iron. Put it in close contact with the diode. And you should see it take off. I don't have my safe guide. Thank you. There you go. Take them. Thank you. Okay, I'm going to put my diode up here. I'm going to put my heat up here. You can see the voltage drop is doing what? Going up, which means the current is going up, right? And then the next thing I'm going to do is I'm going to take freeze spray and spray it, and you see it goes down, right? So the amount of reverse current we get depends on temperature. Okay. So I think it's going to say your observation. So what are you going to say? Well, the temperature goes up, lead current goes up, the temperature goes down, lead current goes down from your observation. That's that section of the lab. I got any questions? And Bernard will just have to get it. Talk to you when it first comes back. So how are we doing on the other section of the lab? Y'all okay on those? Now what you're going to have to do, guys, and this is where you need to get my book and make sure you set up your scale on your graph right. And then next class, what I'll do is I'll make sure y'all, we have problems with people doing graphs. So I'll show you how that's supposed to look out. So what we're shooting for is we're shooting for a characteristic curve that looks like this, right? So does the diode drop exactly 7/10 of a volt? No. So if you ever see that question on a test, you're going to answer false, right? So y'all are working on this side right here. So this guy comes up, and once it starts conducting, it has a slight slant to it, right? So our slant could be all the way up to 1.1 volt, right? You understand? And then what we just did is we did this side over here, and then we're going to we did this side right here. Now they've only given you three marks on the negative side on your graph, so we'll have to see what to do about that. So we did this in class, and then this is what y'all are doing right here when you do your graph, and you'll see it does this slightly when you do your graph. And over here, like I said, they didn't give us enough room, and we can't get over 120 volts anyway, so we only get 3 voltages on that side over there. So questions? So guess what? If y'all want to take a break, you need to do it now. Test starts at 10:30.